Good morning dear students. In this video I am going to give the complete explanation regarding the third unit. Okay, so in this third unit we are having 6 different topics. So we will discuss one by one. The first topic is cloud computing and service models. Simply, so this concept is nothing but types of clouds based on deployment model and service model. So you already know it, based on deployment model. So we are having 3 different type of clouds: public, private and hybrid. And based on service model we are having 3 more types. Those are IaaS, PaaS and SaaS. So we are going to discuss about these 6 different types of the clouds, and we will see how we need to present the answer if they have asked regarding such a questions. Okay. So first of all, in this we are going to discuss about deployment models of clouds. That is nothing but public, private and hybrid clouds. So cloud computing maintains dynamic resources to deliver large number of services to end users. So dynamic resources in the sense which will be provided based on the requirement, not on static wise. So not the fixed resources. So how much we required and until how much time, so based on that, so dynamically the resources will be provided, okay, to the end user. So cloud computing is a high throughput computing. HTC stands for high throughput computing paradigm, whereby infrastructure provides services through a large data centers. Okay, so especially for the clouds, we can able to get the resources from the data centers only. So data center is nothing but which consists of several servers of different types. Okay, so the servers will be used for storage purpose or networking purpose or different types. Okay, computation purpose. Okay. So next, the cloud offers significant benefit of IT companies. Actually, so if you don't have the cloud computing, initially the IT companies, they should have to maintain their own hardwares. Okay, so to maintain that hardware, they need the administrators also. And all the softwares, system softwares and everything should be managed by them only. But because of the cloud, so they can able to avoid all these things. The cloud offers significant benefit of IT companies by avoiding setting up their own hardware and managing system software. So cloud computing applies to a virtual platform with elastic resources put together by on-demand provisioning of hardware, software and databases dynamically. So cloud computing applies a virtual platform. We already know that every cloud is especially based on the virtualization concept only. If you virtual all the operating systems, all the hardware parts, then only they will come under a single system image. Okay, so like that the dynamic resource provisioning can be happened. Here elastic resources in the sense dynamic resources only. So now we will see the different type of clouds one by one. So first of all, public cloud. A public cloud is accessed by any user. Public in the sense it can be accessed by any user and is built over the internet and on pay as you go basis. Okay, so this is accessed by anyone and it is built by using internet and especially based on pay as you go, means how much we will use, that much we need to pay for it. And many public clouds are available so in the market right now. So including them, some of the examples we are having here: Google App Engine GAE, Amazon Web Services AWS, Microsoft Azure, IBM Cloud and Salesforce.com. Next, a public cloud delivers a selected set of business process. The application and infrastructure services are offered on a flexible price per use basis. Price per use basis in the sense same like that only, pay as you go. So whatever we have used, that much we will pay. Okay, so next one, private clouds. So if you have seen the private clouds, especially it is built within the domain of your intranet owned by a single organization. So especially if any information or storage or tools and frameworks using for development, so that should be limited to the organization only. So those are confidential. So that's why those will not be disclosed to all the people. So that's why, so that information, that resources should be circulated and should be provisioned within the organization. So in such cases, we will use the private cloud only. So it is owned, managed only by the client. So its access is limited to the clients and their partners who are there in the organization. Only that people can able to access that cloud services. Private clouds give local users a flexible and agile private infrastructure to run service workloads within their administrative domains. Okay, so a private cloud is supposed to deliver more efficient and convenient cloud services. So since it is a public cloud, so much of rush will be there. So many members, they are trying to access the resources. Coming to the private cloud, so it is very secure and private, and it can able to deliver very efficient and convenient cloud services. Okay, so even for this one also, private clouds, we will have some different examples. IBM RC2, so like that, so which are developed within the limit of the organization. Those are comes under private clouds. So next, let us come to the hybrid clouds. So it is a combination of both public and private both. See, if you have seen, a hybrid cloud is built with both public and private clouds. Private clouds can also support a hybrid cloud model by supplementing local infrastructure with computing capacity from an external public cloud. Okay, so mixing of private and public, right? So private clouds means, so it will take local infrastructure, means local hardware parts, and computation capacity, so means the servers and databases, storage and all these things, so they will take from the public cloud. Okay, so now it is a mixing of public and private both, right? So that's why we are calling it as a hybrid cloud. So for example, here we are having some examples of hybrid clouds and one situation also which will illustrate how it is a combination of public and private both. For example, if you have seen, research compute cloud means RC2 is a private cloud built by IBM. So that interconnects the computing and IT resources at 8 IBM research centers scattered throughout US, Europe and Asia. So actually RC2 is it's a private cloud, but it will manage all the resources in the global space. Okay, so that's why it is becoming as public also. So that's why it is a combination of both, means hybrid. A hybrid network cloud provides access to clients and the partner networks and third parties also. Public clouds promote standardization, preserve capital investment. Standardization means it will give proper standard of the services and preserve capital investment in the sense, so burden will be less, right? So capital investment should be less, so that's why. And offer application flexibility, we can able to access the applications flexibly, so from wherever it is. Okay, so private clouds attempt to achieve customization and offer a higher efficiency, security and privacy. Hybrid clouds operate in the middle with many compromises in terms of resource sharing. Okay, so this is about the hybrid clouds. And next, let us come to the service models of cloud computing. So there are 3 different models of cloud computing: IaaS, PaaS and SaaS. The abbreviations, if you have seen, IaaS means infrastructure as a service, where we will provide the infrastructure, means hardware parts as a service. Next one, platform as a service. Next one, software as a service. Let us see one by one. So first one, infrastructure as a service. So IaaS is also known as hardware as a service, means here especially infrastructure in the sense hardware simply. Okay, so these hardware we will provide as a services for the organizations. So it is a computing infrastructure managed over the internet. So the main advantage of using IaaS is that it helps users to avoid the cost and complexity of purchasing and managing their own physical systems, means own physical hardware parts. So especially if an organization, if you have seen, for the development they need so many systems they need for the servers basis also. Okay, so instead of maintaining all those systems and purchasing them, the cost will be reduced by taking that services for rent from the clouds. So here we have some characteristics of IaaS. So resources are available as a services. So that is the first thing. So next characteristic, services are highly scalable. Scalable in the sense capable. So next, dynamic and flexible. You know it already. So these resources will be dynamic and flexible. So we can able to access these resources by GIE and API based access. GIE in a sense graphical user interface. Okay. So next, automated administrative tasks. So next, let us see the examples for IaaS clouds: DigitalOcean, Linode, AWS, Azure, Google Compute Engine, GCE, Rackspace, and Cisco Meta Cloud. All these are the examples for IaaS type of clouds, means infrastructure related clouds. So next, let us see normal architecture of it. So applications and data runtime. So these things are common in all three service models, IaaS, PaaS and SaaS, but only which resources we will maintain is different. Here from the starting bottom onwards: networking, storage, servers, virtualization, operating system, middleware, runtime, data and application. All these are the 9 different services provided by clouds. So now see which services will be offered by IaaS. In terms of IaaS clouds, especially these 4: networking, storage, servers and virtualization will be managed by the cloud provider, and remaining everything should be maintained by us. Okay, so I have given the example also, real-time example also, for better understanding in the class. Okay, so as of now you just remember like this. So total 9 different services will be provided by any type of clouds, but based on our requirement we need to select the cloud. So for example, if for our organization we need only networking, storage, servers and virtualization only, so then we can adopt this cloud, because in this these 4 things will be given by the cloud provider, and remaining we should have to maintain. Okay, so next one, platform as a service. So PaaS, cloud computing platform, is created for the programmers, especially for the development purpose. So it will maintain tools, frameworks and the softwares whichever required for the development. Okay, so these services provide that one only, software, tools and frameworks to develop an application. So let us see the characteristics of platform related cloud. Accessible to various users via the same development application. So next, it integrates with web services and databases. For the development, definitely we need to integrate with the web services and the storage also, backend also, right? So that's why. So next, builds on virtualization technology. So resources can easily be scaled up or down as per organization's need. Virtualization technology. See, because of this virtualization technology, simply this statement meaning is the resources can be dynamically provisioned. Scale up means whenever the requirement is more, then the server will up. Whenever the requirement is less, then server it will down. So that's one only, this. Okay, so next one, support multiple languages and frameworks, especially for the development, right? So that's why whatever the need of the programmer, so it will provide that languages. So let us see the infrastructure of it. PaaS, same like that only, previously 9 different services will be provided by each and every cloud. In this PaaS type of cloud means networking, storage, servers, virtualization, operating system, middleware and runtime. These will be provided by the cloud, and data and application should be provided by the should be maintained by us, managed by client in the sense. So who are the clients organization, they will maintain these 2 things, and remaining all these services will be provided by the cloud. So wherever we need networking, storage, servers, virtualization along with operating system, middleware, runtime, all these things, then we need to adapt for a PaaS type of cloud. So let us see some examples of PaaS type of cloud. AWS Elastic Beanstalk, Azure, Heroku, Force.com, GAE, Google App Engine, Apache, Stratos, Magento, Commerce Cloud, OpenShift. All these are the examples of PaaS, platform related services. So next, let us see software as a service, last model of it. Okay, so if you have seen this one, the SaaS is also known as on-demand software, means here we will provide software as a service. Okay, so it is a software in which the applications are hosted by a cloud service provider. Users can access these applications with the help of internet connection and web browsers. So after completing the development and everything, so that application will be maintained, right? So those services, software maintenance especially, so that is nothing but software as a service, SaaS. So if you have seen the characteristics of it, managed from a central location, hosted on a remote server. Remote server means it will be somewhere else in the internet. Okay, so accessible over the internet. Users are not responsible for hardware and software updates. Okay, so infrastructure and PaaS, everything is over. So in only SaaS, only software will be maintained. Okay, so next one, if you have seen the examples of SaaS related cloud, BigCommerce, Google Apps, Salesforce, Dropbox, Zendesk, Cisco WebEx, Slack and GoToMeeting. So all these are the examples of SaaS, software as a service clouds. So let us see the architecture of it. Among networking, storage, servers, virtualization, operating system, middleware, runtime, data and application. So 9 different services will be managed by completely cloud provider only. Okay, so here in this type of node, especially everything will be maintained by cloud providers. Okay. So this is the first topic. Now the second topic is data center design and interconnection network. So if we have seen, a data center is nothing but which is consists of different servers, large number of servers. So through a huge interconnection network. So these servers will be connected by using interconnection network. In data center can be categorized as two different types: large scale data centers and small modular data centers, based on number of servers it is having. So if it is having less number of servers, means hundreds and thousands like that, so then it is a small scale data center. If it is having thousands and lakhs of servers, then it will come under large scale data center. Okay, so and one more thing, operation cost. So that one we will discuss in the next topic. So under this we are having 5 different concepts now. First one, warehouse scale data center design, means warehouse scale in the sense the data center, it will be fixed to one space, okay, in one location only. So that is nothing but warehouse. A data center may contain 1 lakh servers to 1 million servers also. Okay, so generally a data center, so it consists of less number of servers, like minimum 1000 to 1 million servers also. The operation cost will be low in large data centers as compared to small data centers. So for this I have given the real-time example also. Okay, so especially in large data centers it will have a huge business. Okay, so that's why the operation cost will be less. Coming to the small data centers, they are having very small type of business, right? So that's why the cost will be more. Approximate monthly cost to operate a 400 server data center. Here we are seeing one example of 400 server data center. In the sense, it is a data center having 400 servers. Is estimated by network cost 13 rupees for Mbps, for 1 Mbps. Mbps in the sense megabytes per second. And storage cost will be 0.4 per GB. So these unit costs are greater than those of 1000 server data center. So 1000 server means, so it is large compared to 400 server data center. But in 400 server data center only cost will be more. In 1000 server data center cost will be less. So that's why we are saying in large data center the cost will be less. The network cost to operate small data center is about 7 times greater than, and the storage cost is 5.7 times greater as compared to large data centers. So generally this will be the scenario. Okay, so as compared to large data centers, in small data centers the database cost will be 7 times more, and storage cost will be operation cost will be 7 times more, and storage cost will be 5.7 times more. Next, hardware requirements of data centers are, so generally what we need to establish one data center in the sense servers. To keep that servers we need racks. To connect that servers we need cables and as well as power equipment. Next, to cool that many systems we need cooling system, and principles and procedures. So we will have in data centers some rules and regulations, right, where we should have the cooling room where we will have the networking part, and like that it is having some principles and procedures. Okay, so cooling system in the sense, especially even if you have considered a normal room also to maintain that, so if you are having any normal computer, so after continuation use of that system, so it will generate some heat. Okay, so even if you have considered labs also, computer labs, so many systems will be there, so it will generate heat. So just to cool down that systems for better performance, we are having the ACs in computer labs. In the same way, here servers in the sense, those are the systems with the highest configurations. So that's why while they are working, they will also generate the heat. Just to cool down that systems, we need cooling system definitely. So that is one of the important concept in data centers. Okay, so that is the next concept here, cooling system of a data center. In data center, there is 4 feet gap between, especially here we are having one diagram, cooling system, how the cooling system in data center is there. Okay, so let us see this diagram. So in this, so this is the flooring slab and this is the flooring tiles. Flooring slab in the sense, so under the tiles we will have a with the concrete we will just give the slab, right? That is nothing but floor slab, and here floor tiles will be there. If you have observed here, there is so much distance gap between floor slab and floor tiles. So this gap is almost, it is about 2 to 4 feet in between these two things. 2 to 4 feet gap will be there between floor slab and floor tiles. The reason is, so this is used for 2 different purposes. First one is the cabling can be kept underground, means these servers will be connected by using the cables, right? So these cables will be kept in this space, means underground connection. So another purpose is just to flow the cooling air, to supply the cooling air to the racks and servers. So here if you have observed, this is a data center, this is ceiling, and all these are the racks. Racks in the sense, same like library, we will have the racks. In that racks we will keep the books, right? Same way in data center also we will have iron racks. In that racks we will keep the servers. Okay, so these racks are nothing but the servers. It consists of different servers. Okay, so next, at both the sides here we are having crack unit, CRAC unit, crack unit. Here abbreviation is computer room air conditioning unit. So this is nothing but like AC. So not a single AC is enough to maintain all these data centers. So that's why we need one cooling system especially. So that's why CRAC is for cooling. Here if you have seen, we will supply the liquid from here. Okay, so now let us see. From the crack unit, cooling air will be generated and it will be passed underground, and in between the server space it will be passed here in between the racks. So then obviously this cooling air will be passed to both the sides of the racks. Okay, so servers will be cooled down. So next, the hot air generated by the servers will be, it will be come out from the another direction. So it will be cooling air, and from this side hot air will be generated, and this hot air will be again collected back to the crack unit. Okay, and again this unit it will cool that hot air, and again it will transmit that cool air to the racks once again. So this is nothing but a recycling procedure. First of all, from crack, cool air will be generated and it will be passed to the servers. Next, from the servers, hot air will be generated and it will be transmitted back to the crack unit, and again it will be cooled down and it will be passed to the servers again back. Okay, so this is the recycling procedure. Okay, so next one is data center interconnection network. So how the servers will be connected, so which type of interconnection we will prefer. So that is the concept here. A critical core design of data center is the interconnection network among all the servers in the data center cluster. Cluster is nothing but collection of servers. Okay, so this network must meet 5 special requirements: one, low latency, high bandwidth, low cost, message passing interface, MPI communication support, and fault tolerance. The design of an interconnection network must satisfy both point-to-point and collective communication patterns among all the nodes. Point-to-point in the sense client-server model. Okay. Collective communication patterns in the sense to a group communication. Okay. So next here we are having some points. The interconnection network should be expandable with thousands or even hundreds of thousands of servers nodes. The cluster network interconnection should be allowed to expand once more servers are added to the data center. For example, initially a data center is startup with 400 servers. Okay, so after 1 year the business is good, so that's why they want to expand their business. So that's why they want to add 100 more servers in their data center. Then definitely the interconnection network also should be expanded, right? In between that 500 servers. So that's why the interconnection network also should be expandable if the number of servers are added to the data center. Okay. So next, the interconnection network should provide some mechanism to tolerate link or switch failures. This is nothing but fault tolerance. Okay, so if in case of these servers will be connected by using cables, links and switches, right? So if any link or switch failures, so then it should have multiple paths should be established between any two servers in a data center. Okay, so just to avoid that one, for example, if two servers are connected by using one switch, if that switch has failed or link has failed, then how the communication can be passed from that server? So that's why there should be multiple paths. If in one path one link failed, in the sense from the remaining paths the communication can be passed. Okay. So next point, there are two approaches to building data center scale networks: switch centric and server centric. So especially in switch centric, the switches are used to connect the server nodes. The switch centric design doesn't affect server side. So this is especially based on switch centric, right? Switches. So that's why it won't affect server side. So next one in this third concept is modular data centers in shipping containers. So especially these are the modular data centers. So latest data centers. Okay. So many countries they are using adapted to this technology nowadays just to save the space and for portability of the data centers. A modern data center is structured as a shipyard of server clusters placed in truck containers. We will have large truck containers, right? In that racks and in the racks servers will be placed. It is nothing but a data center, but it is movable from one place to another place. Inside the container, hundreds of blade servers are housed in racks surrounded the container walls. An array of fans forces the heated air generated by the server racks to go through a heat exchanger. So just to cool down that systems, so we will have this equipment. And now we will see what is the reason why we need modular data centers as compared to warehouse scale data centers. Warehouse scale means the data centers will be in a fixed location. Modular data center means that data centers will be movable from one place to another place location. Okay, so for example, if you are having any water scarcity, if you are having any power scarcity like that, then the data center should be movable from one place to another place where the resource is available. So that's why the modular data centers came into existence. So coming to the warehouse scale data center, if you want to change the data center from one location to another location, it is a huge burden just to maintain another space for it and the installations of all the racks and the servers and the cable connections and everything. So it is a huge burden. So that's why if you are having the modular data centers, then it is very easy to move from one place to another place based on our requirements. So that's why we are seeing here the modular data center leads to relocate data centers to higher computer density, mobility to relocate data centers to better locations with lower electricity cost, better cooling water supplies, sophisticated cooling, and especially one more point here, sophisticated cooling system enable 80% of reduction in cooling cost as compared to traditional warehouse scale data centers. Whatever we have seen previously, that diagram, that is the traditional warehouse scale cooling system. As compared to that one, by using sophisticated cooling system means, so we will go and we will recharge the cooling here. Okay, so by using this one, 80% of the cost will be reduced. One of the examples of modular data centers we are having is SGI ICE Cube Modular Data Center. So this is one truck container data center, one examples for it. So next one, fourth one is interconnection of modular data centers. Okay, so in the first topic we have seen warehouse scale data center. So in second topic, interconnection of that one. In third topic we have seen modular data center in shipping containers, and in fourth one we are going to see interconnection of that modular data centers. A server centric B cube network interconnection a server center here, especially we are going to see one example B cube network interconnection. This is one example for modular data centers to be connected by using the interconnection. Okay, so here the servers are represented by circles and the switches by rectangles. Means here we are having the diagram. Let us see this diagram. These circles are nothing but the servers and these rectangles are the switches. So now let us see levels we will have. Level 0, level 1. So switches we are 0, 0, 0, 1, 0, 2, 0, 3. So different combination of servers will be connected here with 0, 0, 0, 0, 1, 0, 2, 0, 3. 1, 0, 1, 1, 1, 2, 1, 3. 2, 0, 2, 1, 2, 2, 2, 3. 3, 0, 3, 1, 3, 2, 3, 3. So these are the servers and the switches. And in the next level, so we have seen, right, just to avoid the fault tolerance, the multiple paths should be there in between the servers, right? So that's why here, see, this switch is connected to 4 different servers here. 1, 0 server, 0, 0, 1, 0, and 2, 0, and 3, 0. One switch is connected to 4 different servers. Then if in case of any switch failure, then it can be retained by using different multiple paths, other alternative paths. Okay, so this is a connection of B cube interconnection network. It will be used for modular data centers especially. And next, last one in this topic is data center management issues. Okay, so while we are designing and maintaining the data center, we need to keep some points in our mind. So from the design and operational experiences of many data centers in the IT and service industries, so some basic suggestions to manage the resources of a data center are, and some of the people who are regularly maintaining these data centers, right? So they have given some suggestions based on their experiences. Those are making common users happy. How? By giving the low operational cost. So next, control information flow means the information should not be given to all the people. So which one they have required, until that one only we need to give that information. Control information flow. So next, multi-user manageability. So if you are having a cloud, so many members are trying to access that resources at the same time. So that's why multiple users we need to manage simultaneously and efficiently. Scalability to prepare for DB growth, database growth. Okay, scalability means capability. Next, reliability in virtualized infrastructure. Reliability in the sense which will be maintained further, which will not lost. Reliability means, okay, low cost to both users and providers, security enforcements and data protection, green information technologies. So third topic in third unit is architectural design of compute and storage clouds. So actually general definition regarding the internet cloud is, so it is a public cluster of servers provisioned on demand to perform collective web services or distributed applications using data center resources. Okay, so these explanations, these definitions, so many times I have explained clearly word to word. So once again, so internet cloud in the sense, so it is a public cluster of servers. Cluster of servers in the sense, a group of servers is nothing but a cluster. Okay, and these resources will be accessed by anyone. So that's why we are calling it as a public. So that's why an internet cloud is a public cluster of servers. So what we will do, these servers will be provisioned, means supplied on demand to perform collective web services or distributed applications using. So how it can be possible? By using data center resources only. Okay. So next, here 4 main concepts we are having: scalability, virtualization, efficiency, and reliability. Scalability in the sense capability. Virtualization means combining as a single system image. Efficiency means effectiveness to provide quality services. Next, reliability in the sense without any loss of the data. Reliability, it will relays for a long time. Okay. So these are the 4 design goals of cloud platform. Cloud support web 2.0 applications. Cloud management receives the user request. So initially it will happen cloud management. So it will raise the user request and finds correct resources, what are those, and it will be provisioned to the users who are requested for that resources. So in this first topic is a generic cloud architecture. Okay, so if you have seen here, this is one generic cloud architecture diagram. So your clients will be there. Okay, so they will check the service catalogs, in a sense for each and every cloud. So what are the different type of services they will provide? So they will just mention as the catalogs, right? So that's why this one. And here we will have one security and performance monitoring. Once the resources have provisioned to the user, then how the performance of that resource, whether it is working properly or not, and that one. And monitoring in the sense, and if you have given a storage server for one organization, then how much capacity they have used, that one we need to monitor. Based on that one only, right, we will give the billing. Okay, we will give the bill for the user, so they will pay the amount for it. Okay, so that's why security and performance monitoring is that one. So next, resource provisioning, virtualization, management, and user interfaces. So especially we can able to access the clouds by using user interfaces only. Okay, user interfaces will be there. By using that one, we can able to access that cloud resources. User interface is nothing but through which the user can able to interact with the application. Okay, so here cloud platform provisioning of virtualized compute, storage, and networking resources plus software and data sets from multiple data centers to satisfy the demands of multi-tenant applications. Why multiple data centers? In the sense that one, simply if you have adapted to only a single data center, then if in case of any server down and system failures, then it will be happened in all the branches of that organization. For example, if you have seen Google Cloud, okay, Google Cloud have branches in global space in different locations. Different Google Clouds will be there in different worldwide. Okay, so then if one failure has occurred in one branch, then that will be happen in the remaining branches also. It is common because all the branches of same organization will maintain the same infrastructure, same hardware parts, and same operating softwares also. So that's why, just to avoid that situation, so if we have adapted to different clouds, okay, different company clouds, then if there is a problem in Google Cloud now, so then IBM Cloud will sustain our requirement. Okay, so that's why we need to depend on multiple data centers. Next, trusted delegation, reputation systems, and these are the responsibilities of the client. So once the resource has provisioned to the client, so they should be very controlled, and they should be very obedient, trustworthy. So trusted delegation, reputation systems, and data coloring for protecting the data, protecting the provisioned data. So this is the user responsibilities. And finally here we are having data centers. So this is generic architecture. So whatever is there in the diagram, that one we will explain in the matter. Okay, so very important. So next concept is layered cloud architectural development. So here we have cloud development in layers wise. First one, infrastructure layer. So next we are having platform layer. After that, application layer. Okay, so infrastructure layer, we will call it as IaaS, HaaS and DaaS also. Okay, so now see, especially in this architecture, so this is the initial layer. The first layer which will be formed is infrastructure layer, and it will be used as a foundation layer for the next layer. It will be used as a foundation layer for the next layer, platform layer. And once the platform layer has formed, and again it will be used as a foundation layer for next layer, application layer. So once all the three layers have formed, then provisioning of both physical and virtualized cloud services. Okay, so later here we are having three different clouds again: public clouds, hybrid clouds and private clouds. Mixings of public and private, right? So that's why in between we have mentioned hybrid clouds. This is over internet, this is over internet. So especially hybrid cloud will be formed by using internet or intranet also. Okay, internet also. Okay, so this is the layered architecture. So next one we are having virtualization support and disaster recovery. Virtualization support means one of the special feature the cloud computing have, that one is virtualization concept. Because of the virtualization only, all the different hardware parts, all the different operating systems, they will be comes under a single system image. They can be used as a single system. So that's why resources can be shared dynamically. Okay, so this is the main importance of that one. Of servers on a shared cluster consolidates web services. Cloud users do not need to know what they are doing and which systems they are working on. So all these things. So especially in virtualization, they will come under single system image, right? So that's why the user, they need no need to know about which system is working on your application. So it is nothing to the users, because so finally they just need the output. Okay, so in virtualization, any system can able to work on that application. So we don't know that data. Because of that one only, so it is very private and secured. So next for disaster recovery. So disaster recovery in the sense, if in case of any failure, so how we can able to recover the data. So that is nothing but disaster recovery. So especially we will use VM cloning for disaster recovery. So generally, traditionally, if you want to recover, so if you have kept this topic aside, VM cloning, so generally in traditional way, so in traditional disaster recovery, if one physical system has failed, so then this is the procedure to recover all the data. So first we need to configure the hardware. After that we need to install the operating system. Next to configure the operating system. After that install backup agent. So next start single stack automatic resources and restore virtual machine configuration and start data. This is the procedure. This much of procedure will be there, and the time taken for this one is very more, and the complexity also more. So to do all these procedure, it is very expensive, time taken, slow and complex also. So that's why instead of using traditional recovery, so we need to have another alternative method, that is nothing but VM cloning. So in VM cloning, so whatever we have discussed, that one only there here. Okay. See, traditional recovery includes hardware configuration, installing and configuring operating system, installing backup agent, and long time to restart the physical machine. So we end up with a much faster and shorter disaster recovery, which takes only 40% of the time as compared with traditional recovery procedure. So VM cloning, it will take only 40% of the time as compared to traditional recovery system, that is cloning of virtual machines or virtual machine cloning. So in this, for every virtual machine running on local server, a clone virtual machine will be created on a remote server. Okay. So it will be as a duplicate copy. Okay. So among all the clones of virtual machines, only one needs to be active. Okay. So they will be created, but they will be in a suspended mode. So among all the clones of virtual machines, only one will be active. The remote virtual machine should be in a suspended mode. Okay. So a cloud control center should be able to activate this clone virtual machine in case of failure of the virtual machine. If virtual machine failed, original virtual machine failed, then who will take that responsibility? So cloud managers, they will take the responsibility to make it active. So how it can be possible? By taking a snapshots of virtual machines to enable live migration in minimum time. Snapshot in the sense, what is the procedure have done previously, so till that time. So that one they have in the command prompt, they will just take the images of it regarding the previous procedure. So by using that one, they can able to understand what is the procedure, where it has struck that process. So it will be migrated and it will start the procedure again. The migrated virtual machine can run on a shared internet connection. Only updated data and modified states are sent to the suspended virtual machine to update its state again. So, and finally last one is architectural design challenges. Here we are having 6 different challenges. First one, service availability and data lock-in problem. So we have discussed previously, to achieve HA means higher availability or service availability, all are same. Okay, so it is better to adopt multiple cloud providers than using a single cloud provider. So I have told you the reason previously. So if in case of any system failures, so it will be same infrastructure hardware will be there in all the branches of that organization. So that's why just to avoid the service unavailability, so we need to adopt multiple data centers. So next, another availability problem is DDoS attacks, means data distributed denial of service. Denial of service in the sense, so while we are trying to access some websites, we can able to see 505 service not available errors, right? So that is nothing but denial of service. So some criminals, they will try to attempt to stop the services, SaaS providers cut off the services just to decrease the incomes of SaaS providers. Okay, so by making their services unavailable. Okay, so some utility computing services offer SaaS providers the opportunity to defend against DDoS attacks by using quick scale-ups. So they will have some mechanisms also to get rid of these DDoS attacks. So next, challenge 2. Data privacy and security concerns. So nowadays to the internet, especially this cloud is working based on the internet only. So internet means obviously so many type of attacks will be there. Okay, so some of the examples are traditional network attacks like buffer overflows, DOS attacks, spyware, malware, rootkits, Trojan horses, and worms. Just to overcome these attacks immediately with some technologies such as encrypted storage, virtual LANs, and network middle boxes like firewalls and package filters, these will be available. Okay, but many nations have laws requiring SaaS providers to keep customer data and copyrighted material within national boundaries only. That is also required, right? So privacy, that is nothing but. So in a cloud environment, so newer type of attacks also generated day to day. So like hypervisor malware, guest hopping, hijacking, or virtual machine rootkit. Another type of attack, man in the middle. So all these are the attacks. So that's why just to avoid these attacks, the cloud architecture should be designed to defend these type of attacks. That is another second challenge. Challenge number 3, unpredictable performance and bottlenecks. So especially input-output sharing. So especially input-output sharing is the main important problem we need to face, especially in virtual machines. So that is another challenge we need to maintain. Challenge number 4, distributed storage and widespread software bugs. Distributed storage in the sense, once the data is stored, it should be distributed across the systems based on the scale up and scale down on demand. Okay, so next, widespread software bugs in the sense, we have discussed a real-time example also for this. Once in the software any bugs or problems are there, it will be repeated and it will be widespread. So while we are using that software anywhere and at any time, so that's why we need to avoid that software bugs while we are developing itself. Okay. Challenge number 5, cloud scalability, interoperability, and standardization. So as a pay-as-you-go model applies to storage and network bandwidths. Storage in the sense per GB basis. Network bandwidth means Mbps basis. Both are counted in terms of number of bytes used. So computation depends on virtualization level. So GAE means Google App Engine. It is automatically scales in response to load increases and decreases. So GAE, Google App Engine have some mechanisms. So it will automatically response whenever the requirement is more. So it will just scales up. When the requirement is low, then it will decreases the services. Okay, so this is nothing but scalability, interoperability. So dynamically it will provide. Users are charged by cycles used. AWS charges by the hours per the number of virtual machine instances used. So these are the charging criteria they are having. Challenge number 6, last one, software licensing and reputation sharing. Many cloud computing providers originally depending on open source softwares because licensing model for commercial softwares is not ideal for utility computing. So commercial software for licensed software, it is not stable, so it will be changed, and license also it will be changed. So that's why every time they can't purchase that license, right? So that's why they will try to adopt for the open source softwares only. The solution for this is either the open source should become popular or commercial software companies to change their licensing structure to fit for cloud computing. Okay, so this is either of one should be happened. Either open source should be become popular. Okay, it should meet the requirements of the clouds. Okay, either or commercial software companies change the licensing structure to fit for all the cloud computings. Okay, so either two of these things should be happened. So this is regarding third concept.